called as heat transfer, and the first topic is called as heat and its effect. So basically, what is heat? So heat is a measurable form of energy. Energy that you can measure, that is called as measurable form of energy. So as we know, heat always flow from, heat always flow from high temperature body to low temperature body. That means under the influence of temperature difference, heat flows. Next one, example. So when we talk about temperature, so temperature is defined as degree of hotness or coldness of a body. So there is a term that is called as temperature. So what is temperature? Temperature is nothing but degree of hotness, or coldness of a body. Coldness of a body is called as temperature. So different substances are given and we need to tell whether the body is hot or cold. Example, tea. So tea is hot. Coffee, hot. Ice, when we talk about ice, it is cold. Why? Because the temperature is 0 degrees centigrade. Ice cream, cold. Cooked rice, hot. Frozen meat, it's cold basically. So temperature defines the degree of hotness or coldness of a body, while heat always flow under the influence of temperature difference. So heat flow from high temperature body to low temperature body unless and until it maintains equilibrium. Example, suppose if I take a body A, so this is body A, and the temperature of body A is 100 degrees centigrade. We have body B whose temperature is 0 degree centigrade. When these two bodies are connected together or they are brought in physical contact, so transfer of heat will take place. So heat flows from high temperature body to low temperature body unless and until the temperature of both the bodies is 50 degrees centigrade. So this condition is called as thermal equilibrium. This condition is called as thermal equilibrium. That means in this particular case, temperature of both the body remains same. Next one. Is heat measurable? Yes, we can measure heat. We can measure heat. And we can measure temperature also. So in order to measure temperature, we use a device that is called as thermometer. We use a device that is called as thermometer. So thermometer is a device that is used to measure temperature. It is a device that is used to measure temperature. That is called as thermometer. Now, we have basically three types of temperature scale. So temperature scale. So first one is degree centigrade or degree Celsius. Degree Celsius. Second one is degree Fahrenheit. Third one is Kelvin. Kelvin. Next, we also use Rankine and Reaumur. Two more temperature scale. Rankine and Reaumur. R-E-U-M-E-R. So we have two more temperature scale as Rankine and Reaumur. So these are the scales. These are the scales to measure temperature. For example, when we talk about Celsius scale, Celsius. So Celsius. So there is called as lower fixed point, LFP. So lower fixed point for Celsius is 0 degree centigrade. I repeat, lower fixed point for degree centigrade is 0 degree centigrade. So LFP, lower fixed point. And we have UFP. UFP is called as upper fixed point. We have two things, LFP and UFP. For degree centigrade, LFP is 0 degree. Upper fixed point is 100. Upper fixed point is 100. So number of division on the scale. So that is upper fixed point minus lower fixed point. So 100 minus 0 is 100. 100 minus 0 is 100. Similarly, lower fixed point for degree Fahrenheit. That is 32. And 212, 212. That is upper fixed point for degree Fahrenheit. So if you take the difference of these two, we have number of division 180. 180 is the number of division on Fahrenheit scale. When we talk about Kelvin, so lower fixed point for Kelvin is 273.15, while the upper fixed point is 373.15. If you subtract these two readings, you have 100. So number of division on Kelvin scale is 100. Number of division on Fahrenheit scale is 180, while number of division on centigrade scale is 100. You can also convert one scale into another scale. We have a formula for it. So in order to convert degree centigrade into degree Fahrenheit, it is important to note that in order to convert degree Celsius into degree Fahrenheit, so we use a formula C by phi is equal to F minus 32 over 9. C by phi is equal to F minus 32 over 9. What is the C? C is degree centigrade. What is F? Degree Fahrenheit. 32 is the lower fixed point, and we have 5 and n. So these are the coefficients. Second formula that you have to remember, conversion of degree Celsius to Kelvin. You can convert degree Celsius into Kelvin by using this formula. K is equal to C plus 273.15, or K is equal to C plus 273. So in higher standards, we use 273.15, but K is equal to C plus 273 is also perfectly fine. No issue at all. What is K? K is basically Kelvin scale. Kelvin. And what is C? C is called as degree Celsius. Example. One example. If I want to convert 10 degrees centigrade into Fahrenheit. Question. Convert 10 degrees centigrade into Fahrenheit. So degree centigrade into Fahrenheit, you have to use this simple formula. So the formula is C by phi is equal to F minus 32 by 9. This is the formula. So use the formula. So what is C? C is basically 10. So 10 over phi is equal to F minus 32 over 9. 5 times 2 is 10. Now 9 times 2, you need to just cross multiply. So 9 2s are 18. 18 is equal to F minus 32. Now bring this 32 from left hand side to right hand side. It will change its sign. So F 18 plus 32 is equal to F, which is nothing but 50 degree Fahrenheit. So in case of 10 degrees centigrade into Fahrenheit, so the required answer is 50 degree. So 50 degree is the right answer. So this is how we convert one scale into another scale. Next. So how is temperature a measure of heat? So we have a relation between heat and temperature. If I use the result, Q is equal to mc delta T. So this is the formula that you need to remember. Q is equal to m into C into delta T or T. So Q is basically heat. What is M? M is basically the mass. M is mass. C is called as specific heat. Specific heat. And T is what? T is basically temperature. So I repeat, we have a relation between heat and temperature. So the formula is Q is equal to mc delta T. I repeat, M is mass, C is specific heat, and T is basically temperature. Now it is important to note the unit of heat, Q. So as we know, the unit of heat is joule. Heat unit is joule. So SI unit of heat is joule. SI unit of heat is joule. is joule, while the CGS unit of heat is erg, 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 erg. This is only for your general knowledge. So SI unit is joule and CGS unit is erg. In case we also have a for force, you can see for force also. So force SI unit is Newton, Newton, and CGS unit as dyne, CGS unit as dyne. I repeat, SI unit for heat is joule, CGS unit is erg. Similarly, for force, SI unit is Newton, CGS unit is dyne. It is important to note that. Now next, effect of heat. So first effect of heat, it will raise the temperature of an object. So first one, rise of temperature, rise of temperature. Now it is important to note that in case of heat transfer, so when heat travels from one body to another body, we have three modes of heat transfer. So first one is called as conduction mode, conduction. Second one is called as convection, convection. And the third one is called as radiation, radiation. So we have three modes: conduction, convection, radiation. We'll study in detail in the next slide. So first one is conduction. These are called as mode of heat transfer. Modes of heat transfer, heat transfer. So first one is basically conduction, second one is convection, third one is radiation. Now we'll talk about change in state, change in state. So suppose we have solid, we have liquid, and we have gas. So as we know, matters are classified under three categories. Matter are classified under three categories. So we have solid, we have liquid, and we have gas. Solid, liquid, and gas. And we also use plasma state also. Plasma state. But as far as our syllabus is concerned, we have only solid, liquid, and gas. So we are talking about conversion of state, conversion of state. So it is important to note that as far as solids are concerned, so the molecular, so intermolecular force of attraction between solid is very high. So intermolecular force, that means the force of attraction between the molecules of solids, this is very high. So solid is very high as compared to liquid, as compared to gases. Second important feature, that is called as intermolecular spacing. This is first one, intermolecular force. Second one is intermolecular spacing. Intermolecular spacing. Intermolecular spacing. That means the distance between the molecules. If you observe these distance, we are talking about these distance, this distance. So this is called as intermolecular spacing. So as far as intermolecular spacing is concerned, the intermolecular space of gases is very high as compared to liquid, as compared to solid. So due to less intermolecular spacing in solid, that is the reason solid has perfect shape. They have solid structure, perfect shape. When we talk about gases, they do not have a shape of their own. They can take the shape of the container in which they are placed. So that is the reason the gases can take the shape of the container. Why? Because intermolecular spacing is very high. As far as intermolecular force is concerned, it is very low. Now you can convert one state into another. If you observe, you can convert one state into another. Example. So when we talk about solid. So when you heat solid, that is melting phase, it converts into liquid. When you heat further liquid, vaporization phase, it converts into gas. Sometimes solid directly converts into gas. Example, camphor, naphthalene balls. So this process is called as sublimation. This process is called as sublimation. So sublimation means direct conversion of solid to gases without passing through liquid stage. I repeat, in case of sublimation, sublimation is a process. Sublimation is a process in which solid converts into gases without passing through liquid phase. Without passing through liquid phase. So it is called as sublimation. Example of sublimation: camphor, naphthalene balls, solids carbon dioxide, solid CO2. So this is nothing but the conversion of states. I hope the concept is clear. Yes. Now, few definitions regarding state of change, right? So the following terminologies are used to describe the change in the state of matter. So first one is called as melting. So melting means change of solid state to liquid state. It is called as melting. Freezing, liquid state to solid state. It is called as freezing. Vaporization, liquid state to gaseous state. It is called as vaporization. Condensation, solid state to liquid state is called as condensation. I repeat, melting means solid to liquid, freezing, liquid to solid, vaporization, liquid to gas, condensation, gas to liquid. So it is called as condensation. Next important term that we have already done, that is called as sublimation. So sublimation means change of state, that is solid, from solid to gaseous state without passing through liquid state, that is called as sublimation. Example, we have dry ice, camphor, naphthalene balls. Now next important point, that is called as deposition. So it is a process opposite to sublimation. So in this, substance changes directly from gaseous state to solid state. Example, frost. I repeat, it is a process in which substance changes directly from gaseous state to solid state. So deposition means solid to gas. Gaseous state to solid state. It is called as deposition. And sublimation means solid to gaseous state. So it is nothing but sublimation. Gaseous state to solid state, deposition. Vice versa, solid to gas, it is sublimation. This process is called as sublimation. Now it is important to note that kinetic energy of particles. So as we already discussed, the intermolecular force of attraction between the gaseous molecule is very low. So intermolecular force of attraction. As far as solid is concerned, is maximum, liquid, and we have gases. So minimum in gases. So intermolecular force of attraction is minimum in gases. So as a result of which the kinetic energy of gas is higher as compared to liquid, as compared to solid. So kinetic energy will be more. So kinetic energy of particle order is gaseous, greater than liquid, greater than solid. Particle to particle force of attraction, that is called as intermolecular force, maximum in solid, minimum in gas. As far as spacing is concerned, intermolecular spacing is concerned, so it is maximum in gases, then liquid, then in solid. So you can observe the structure of solid. All the molecules, they are closely packed. They are closely packed. In case of liquid, see, they are far apart. They are far apart. In case of gas, the distance is very high. The intermolecular space is very high. Right? That means the gapping between the molecule is high. Next one. Now temperature affecting the change of state. Temperature affecting the change of state. So in this article, we have two major concepts. First one is called as specific heat and the second one is called as latent heat. I repeat, specific heat and latent heat. So I will demonstrate using an example. So suppose we have an ice. Ice, this is basically ice cube. Let us assume the temperature of ice cube as say minus 10 degree centigrade. So when you heat ice, so it will convert into ice of 0 degree centigrade. Ice of 0 degree centigrade. We have ice on. When you further heat, it will convert into water. Water, 0 degree centigrade. When you further heat, this water will convert into 100 degree centigrade water. 100 degree centigrade water. When you further heat, this water will convert into steam. Steam. Of 100 degree centigrade. Now it is important to note that the heat that is required to change the temperature without changing the state. See, state is not changing. We have ice. Only temperature changes. So it is nothing but specific heat. Specific heat. And the formula is Q is equal to mc delta T. mc delta T. Delta T means change in temperature. You can also use small t. So specific heat means the amount of heat that is required. Amount of heat required to change the state without changing the amount of heat required to change the temperature without changing the state. To change the temperature, the amount of heat required to change the temperature without changing state. Without changing state. It is called as specific heat. And the formula is Q is equal to mc delta T. Next one. Now next one. Now 0 degree centigrade ice to 0 degree centigrade water. It is important to note that temperature is constant throughout. Only phase is changing. So we use latent heat. So what is latent heat? So latent heat is defined as, we use a concept of latent heat. Heat required to change the state without changing the temperature. Heat required to change the state without changing temperature. I repeat, heat required to change the state without changing temperature. Change the state without changing temperature. So it is called as latent heat. So in this particular example, we are converting ice to water. So it is called as latent heat of fusion. Latent heat of fusion. Latent heat of fusion. And the formula to calculate latent heat of fusion is Q is equal to mass into latent heat. So Q is equal to mass into latent heat. Q is equal to ml, mass into latent heat. Next one, water to water. State is same, only temperature changing. There is a change in temperature, so specific heat. Specific heat. Q is equal to mc delta T. From water to steam, only state is changing, temperature remains constant. So it is called as latent heat. Latent heat of vaporization. Latent heat of vaporization. Latent heat of vaporization. So Q is equal to ml. We use a formula. Q is equal to mass into latent heat of vaporization. It is called as so latent heat of vaporization. So this is nothing but latent heat of fusion. Q is equal to ml. So I'm just using the term F. LF means latent heat of fusion, latent heat of vaporization.